Let's recap and bring it all together. Reasoning about space and how things move in space. There are two problems that always come up. One is when my vantage point is changing, when I want to see the world from a different perspective. I've seen the world from the perspective of my camera, but now I want to see it from the perspective of my robot. My vantage point changing is one reason to use transforms. Another one is when things actually move in the world. A mobile robot used to be at some location, but now it has moved, and it's at a different location. Again, we use transforms for that. So, in 3D space, points are encoded as four-dimensional vectors. Column vectors always. A transform always has a very specific form. There's a rotation part, there is a translation part, and then 0 and 1 on the bottom. You can use a transform for two different things. First, you can say, my vantage point is moving. I've moved my vantage point to T1. Then from T1, I've moved my vantage point to T2. And then from T2, I am observing point P. Right? I've moved to T1, I've moved to T2, I'm seeing P. Another way of looking at the same problem is P is being observed in coordinate frame C, which is related to coordinate frame B, which is related to coordinate frame A. So I can see point P from the perspective of A. Okay. The other way to use transforms is to say, hey, you know what? It's actually the point that's moving. My vantage point stays the same. So I have a P that has moved in some way, and that has moved again. And this was P old. And after those two moves, now I have P new. So it's so something in the world has moved. Mathematically, these are indistinguishable. Whether it's the vantage point that has moved or the actual contents of the world that has moved, there's no difference from a mathematical perspective, which is why these, if you take away subscripts, superscripts, they look the same. These transform matrices have very, very specific properties. So R is always a 3 by 3 matrix. It has determinant 1. It's orthonormal. And its inverse is its transpose. T is a 3 by 1 vector. And it can really be anything. In robotics, the bottom left, 1 by 3, always zeros. The bottom right, 1 by 1, always 0. So this is the essence of this lecture, the essence of transforms and reasoning about 3D space. And then in the next lectures, we will start looking at how this is used for very specific robotic applications.